Hola, ¿qué tal? Welcome back. Before we begin, for any of y'all that is eager to learn more about how I graph a function, I apologize. I ain't doing that this week. Because why not? Because of this. Got a request from a regular viewer. This lady was having some trouble with her homework in school. Something about a math problem she ain't totally understand. She ain't exactly asked for no video. And I ain't entirely sure she gonna see this one. But here we are. We about to confront a real-life algebra math problem that made an appearance in somebody's math class. Function's gonna have to wait. As you might have guessed by now, it's got to do with this problem to my left. As you can also see, it's a highly complicated problem. Got all different sizes of numbers in it, x's and y's and a fraction. But yo, we in the world of algebra, so we got to deal with it. Maintain a positive attitude as we move forward. The instructions is to simplify, which basically mean make it look less complicated and preferably smaller, so it ain't so many symbols. So that's what we gonna do. We gonna shrink it down. Personally, if I had my druthers, I just start crossing stuff out. But unfortunately, the math of algebra don't work like that. So we got to go another route. And that route is factoring. Take this contraption in the lower left. It goes x squared plus 8xy plus 7y squared. It's known as a polynomial. It's a bunch of terms connected together with pluses and minuses. And this one is a polynomial that's got 3 terms. Uno, dos, tres. So we're going to refer to it as a trinomial, because tri means 3. If it had only 2 terms, we'd be calling it a binomial, but it ain't. Anyway, trinomials, like this one, can very frequently be factored down into 2 binomials. Before I attempt to explain how that makes sense, let me just demonstrate it first. Alright, so let's say, what if I'm right about that? And I really can transform this trinomial into 2 binomials. That would mean, after I did that, it would look like a binomial, which is 2 terms connected by plus or minus, times another binomial. That when you multiply them together, it turned back up into its original trinomial. Can we make that happen? Okay. At this juncture, I ain't gonna go much further than to say that the first terms in these 2 binomials, whatever they end up being, has got to multiply together to make the first term in the trinomial. And these last terms has got to multiply together to make the last term in the trinomial. At least that sounds like it makes sense. So we're going with it for now. Alright, it's only 2 terms, other than the number 1, which we ain't counting for this, that can times each other to make x squared. And that's x and x. Because x times another x is known as x squared. In a similar fashion, it's only 2 terms that can times each other to make 7y squared, which is y and 7y. And I connect them with a plus sign. Now I don't expect none of y'all to believe these 2 binomials is going to times back into this trinomial. At least not until I attempt to times them. And how do you times 2 binomials? I do not recommend you ask your math teacher that, because they probably going to say, just use the FOIL method. We skipping that nonsense for now. Basically, what you got to do is multiply each term in this first group of terms by all the terms in this second group of terms, while at the same time keeping all the terms connected together with pluses and minuses, like they are now. Watch. X times x is x squared. X times 7y, 7xy, because we keep the letters in alphabetical order. Y times x, that's yx. I don't think so. It's xy. Y times 7y, 7y squared. That was the process of distribution. No further explanation on that term for now. Oh, one last thing. Since I got 7 xy's right here and an additional xy right here, I'm just gonna call that 8 xy's altogether. So check that out. When these two binomials got times together, they turn into that original trinomial. X squared plus 8xy plus 7y squared. So now I know I factored it correctly. These two binomials is definitely the correct factors of that trinomial. All right, let's get back to FOIL for just a second. So acronym stand for first, outer, inner, last. And it basically means first term times first term, outer term times outer term, inner times inner, last times last, which ain't nothing but what we did a second ago. When we multiplied each term in this group by all the terms in this group. Because that's the math you gotta do when you confront it with multiple polynomials that got to be timed together. FOIL ain't nothing but a memory device, which you learn so that you only gotta remember a word, but you don't actually gotta remember the math. Now, as long as you're just dealing with two binomials times together, FOIL gonna work great. But as soon as you get confronted with anything other than two binomials times together, you're gonna be lost. Unless you understand the math, which is times each of these terms by all of these terms. And keep them added together with pluses and minuses. Now, I do recommend you learn and understand FOIL just enough to tell the teacher why they're helpful. And why do you math teachers always be teaching us tricks and devices instead of just teaching the math itself, math teacher? All right, let's get back to this problem. So basically, what we did going from here to here was times in two binomials in reverse, because that's what factoring is. It's times in reverse. And we did that based on the advanced knowledge, which we all now got, that there was probably two binomials in existence that would times each other into that trinomial. In a word, we factored. One trinomial, two binomial factors. And now we're gonna trust that the same goes for these additional trinomials that we got to factor to finish this problem. Now this first one we did, that was simple. It was only plus signs. And there was only one option for what two terms you multiply together to make the first term in the trinomial and the last term in the trinomial. But these other two, it's got minuses and pluses and multiple options for what numbers you times together to form other terms. So I guess now you know. Factoring polynomials, it ain't always simple. It's gonna take trial and error, and you're gonna have to practice on your own. But I will walk you through this next one, and maybe the one after that as well. All right, with this one, the first term, it still only got one option for what times together to make x squared, x and x. But it's different numbers you can times together to make 20y squared. But check it out. If I go with negative 4y and negative 5y, then when I'm lining them up down here, x times x, that's x squared. X times negative 5y, that's negative 5xy. Negative 4y times x, that's negative 4xy. Negative 4y times negative 5y, that's positive 20y squared. I can see the negative 5xy and negative 4xy that gets created is going to add together to make negative 9xy, the middle term in the original trinomial. So that means sometimes I can predict, like with this last one, I can predict that negative 4 and negative 4 is going to times together to make positive 16. And they also going to plus together to make negative 8. So that's the numbers I'm going to use. X, negative 4y, negative 4y. Then I double check my work. X times x, that's x squared. X times negative 4y, that's negative 4xy. But hold up, plus negative 4xy again, negative 8xy. Negative 4y times negative 4y, that's positive 16y squared. As predicted, it works. These two binomials is the correct factors. So are these two. And now to complete the problem. What we got to do is rewrite the original fractions, except we're gonna put the trinomials in their factored form. Two binomials, x times x, negative 4xy. Nope. Negative 4y minus negative 5y. Okay. Over two binomials, x plus y, x plus 7y. Oh, don't forget, when you divide by a fraction, you basically just multiply by the flipped over version of that fraction. So I'm timesing for now. X plus 7y, you now on top. Two binomials. X, negative 4y, negative 4y. And now what? Stuff that's on the top and bottom of these fractions at the same time can get canceled out. X minus 4y, you cancel, son. X plus 7y, canceled. Last step, rewrite it as one fraction, leaving out the canceled elements. X minus 5y on top, x plus y, x minus 4y. Sure enough, this one got a lot less symbology in it, so we can consider it to be simplified. Problem complete. Have a wonderful rest of your day. Goodbye.